Where's my water bottle? Here
Okay.
it is.
So, hello and welcome to our second fall presentation. So, amidst all this remote learning, many robotics students have lost the opportunity to obtain hands-on experience. Um, so, Team FTC 14020 Nemesis Prime has been reaching out to professionals asking to give presentations about themselves, their personal journey, and about basically a fascinating topic about their specific profession. So today we have Mr. Mark Martinez, who is a software developer who specializes in machine learning, data science, specifically in computer vision. And also in his free time, he enjoys performing and has made a side career for himself as an opera singer. So thank you so much, Mark, for being with us.
Hi, thank you, Matt, for inviting me, and thank you, everyone listening in. Um, sure, how do we start this?
So I'm going to ask you a few questions about your professional journey, and then we're going to move into your specific topic. So first, what do you currently do for a living?
So currently, I am a software engineer that does a lot of work in data science more so right now, but like also circa a month ago, basically more machine learning and computer vision in particular. And what that is the simple thing is teaching computers to see. So like that's kind of nebulous or it's kind of like a bit broad, but a very applicable example is like TikTok filters or like Snapchat filters. That is what I do. Like that in that realm of like computer science.
Cool. So how did you get there? How did you get to that?
Um, so my path was a little bit circuitous. So it wasn't completely direct. Out of undergrad, I my first job was working at a pharmaceutical company. I was doing data science. Then afterwards, I went to grad school, and in grad school, I kind of just picked. I knew I wanted to do machine learning, which is just a big topic in general. But I kind of stumbled upon computer vision by accident. I took a course in it, and I found it was super fun. Then I ended up doing some research in it and I wrote a master's thesis on Grand Theft Auto actually, and I kind of just stumbled upon it continuously. Out of grad school, my first job out of grad school was more in generic software development, but I wasn't super happy with it. So afterwards, I decided that I wanted a job specifically in computer vision. So then I just looked at some new companies and found a job that did it, and that's how I ended up where I am now.
So along that path, were the things that went really well that you would recommend students to do?
Yeah, so I think what I would recommend is what ends up being the most beneficial to a person is finding things they're really passionate about and really just focusing energy in that. And the reason I say that is, not only are is it good to do what you love just because it's fun, but you work harder and like you become better at it just because you enjoy being better at it. So like when I worked at Square, which is my more generic software development job, like I was just like lukewarm about doing JavaScript, which is like making websites and all of that. But there is a project that I came up with that integrated computer vision and classification in the job that I was doing, and like within that week that I was just like that I came up with the project, I learned the entire iOS stack, so iPhone code, and I never touched that stuff before. And it's amazing how much you can learn and how quickly you can learn when you care about a subject. So that's what I think is super important. Finding something that you love and just finding a way to make it applicable and useful to you in a career.
Just as a side note, for anyone who's watching now, you are more than welcome to post questions in the YouTube chat, and I will be able to see them, and I can ask them in the moment. There is only a small lag between Zoom and YouTube, so you're more than welcome to ask, and it will be asked for you. Also, so you talked about the highs, the things that really worked well for you. Is there anything that you would say that maybe is the norm right now that might be a little overrated? That
I think as for right now, I'm not sure like what is like overrated right now necessarily. I feel like what's popular is a lot of people are getting into coding, which I think is wonderful. I don't think that's overrated. What I do think that is overrated is more specifically it's following a trajectory that you're not particularly interested or care about, and only doing it for whatever reasons, whether it's economic or pressure from family or friends. Like in college, I had a lot of friends that just like kind of went into economics and finance just because they felt like they needed to do that. But if I look at my most successful friends, they studied things that they were good at, but wasn't necessarily the popular it thing. And in the end, because they worked so much harder in what they did and found a way to actually make it applicable to, essentially making money and just like doing stuff, they are far better off than people who kind of just follow the crowd. So I think something that is overrated is just kind of following the crowd. Like it's important to be sensible and like do something that you think will give you a safe future, but at the same time, you shouldn't do that at the sacrifice of being passionate about what you're doing.
Do you want to expand on that in your own personal life, like your passions?
Yeah, totally. So to give an example is right out of grad school, I didn't really think about the job that I was doing. I just kind of took whatever software development position just because I was like, whatever. Like, I'm moving to New York from Princeton, New Jersey, and I'm like, I have these other things. Like, just being in New York is good enough, so I don't have to care about like liking my job necessarily so much as long as it's like in the general field of programming or computer science. But that was a mistake. Like I really should have been picky and like figured out like, oh, I want to do this type of a job. I want to do like machine learning and I want to do X, Y, and Z, because then in the end it would have saved me another year of kind of just being in a job that I didn't care about that much.
Okay. So basically, there's such a big range about programming that you need to find a way to explore that earlier on.
Yeah, and like there are many ways that you can find something super interesting. So I've have friends who were like really into theater actually. So like, and I'm in tech, so it's like lighting and stuff like that. And but they also studied computer science. But they found ways to merge the two together. Like there's like the person that went into that loved theater ended up working for a company that like creates like the algorithms for like lighting stages and stuff like that. So it's like, there is something out there for you if you really do have a passion. And instead of just following the generic route, you should somehow find a way to merge the two together. And because then you'll just really love what you're doing and become an expert in the field.
Cool. So today you said you brought with you a presentation about deep learning. So
Yes,
I'm going to open the floor to you to give your presentation.
sure, sounds good. So this presentation is extremely high level, meaning that I'm not going into really any mathematical detail at all, almost to the point where it's almost too high level. But it's kind of a fun machine learning and computer vision itself is kind of a fun topic. So hopefully this will make sense, and it'll give you a kind of an understanding of what I'm doing and what I've done before. So I'll start now, and I am going to share my screen. Um, so do you see this, Matt?
Yes. I have a question for someone from someone though. So they asked, you might have mentioned it, but why did you choose to go to grad school?
So the reason why I chose to go to grad school was kind of funny. I was it right after my undergrad. My first job was a very PhD heavy research. It wasn't quite a research group, but it was within Johnson and Johnson, the company that I worked for. It was a very heavy PhD group basically. So everyone had advanced educations, and I kind of felt it was if I wanted to become an expert in a field, that I really needed to specialize a little bit more. That's not actually what you really need to do. I have friends that have become experts in fields just by working, but you do need to be mindful of like if you are going to skip the school approach, then you need to really think what type of jobs am I picking because that will direct where you're going. Whereas grad school, it kind of does that for you in a sense where it's, because, in grad school, I focused in on machine learning and computer vision. I, forged my own path in a sense. But I mean, that's the real reason why I just felt like it was an easy way for me to really become an expert.
Hmm.
So shall I begin?
Yeah, go for it.
Cool. So today I'm going to be talking about my master's thesis, which was on deep driving. That's just a cute little name for deep learning within a self-driving car context. So the way I got into uh, self-driving cars actually is really random. I was in Pittsburgh 2016 or 17 I think maybe 2016 actually. And like I happened to get into an Uber that was a self-driving Uber, and I'm like, oh my God, this is so cool. So when I got back to grad school after my little vacation, it was like winter break or something. I'm like, I'm gonna find a lab that does this. And lo and behold, the professor that I was working for a class when I was TAing happened to do this research. So things just kind of lined up really nicely. Um, and self-driving cars, there's a lot of components to it. I didn't touch any of the mechanics, so like I didn't build or do anything, but I worked on the software side. um, so right now I'm going to go a little bit more high level than what I did, but I'm going to be talking about what is deep learning in general. So deep learning is and what is it? So deep learning is a form of machine learning. It's a family of algorithms that are used a lot in really complicated image processing. So here's a couple examples. Like here's an example of what you can do with deep learning, for instance. So this is a video, and if you can see it actually, in this video, a deep learning network, more specific, the name of this particular network is YOLO, which is the dumbest name ever, but grad students don't come up with great names. But as you can see, actually, in this video, a lot of objects in it are actually being labeled real time. So like this is like kind of the type of stuff you can do with deep learning. And more specifically, how this actually happens is you have a deep learning network, which is the little blue bubbles in the middle, and you feed it data in the beginning. So it's like you feed it like a dog, basically. And once you take this image of a dog and you pass it through the network, it goes through multiple layers, and in the end, it outputs a dog. Um, and the way that works is you're basically, so this is another example, another GIF, but like you're taking the input of like the image and you go to the end, and then it calculates the difference. Basically, it's like kind of it's teaching the network in such a way that like you give it data and then it just slowly specializes this network to work better on image data. Um, so what did I specifically do with it? So I did self-driving research on it. So basically, what I did is, well, this was actually just a dog, but basically I did computer vision work on it where I was taking real-time video data and just like kind of partitioning it into different types of things. This is not actually from my research, but this is just like to give an example of what I was doing. But I am essentially just trying to understand the world and separate it out in a way that we as people do it. Because, like, when the big problem or the hard part about self-driving cars is, to us, driving is fairly simple. Like, there's a road that you go down, there's cars that you're not supposed to hit. But like that simplicity needs to be taught. And so, in order to understand that for like a computer, you need to break down the world. And just like in this GIF, like you see like a dog gets broken down to dog and grass and all of that, but you need to do that in real time. Um, so here's another GIF, more specifically the type of stuff that I was doing. So let's say on the left side, you see a car, it's a Tesla in this instance. And on the right, you can see like what's happening in the computer's mind in a sense. It's like it's looking through the entire world space around it and is partitioning it into particular things. So self-driving cars is a huge area. So it's impossible for one person to do everything. And so the area that I specialized in was actually very specific and kind of niche, actually. So what I did was I used, instead of using a lot of real data, we theorized that it's important to have ways to augment or make the data set bigger. And the reason why you need to do that is, in order to make a good algorithm, you need to have a lot of data. That's kind of just the crux of how deep learning goes, or any machine learning algorithm. But the problem with data, specifically car data, is there isn't too much of it, and it's hard to get good data. So the way it currently works is like Google and these other big companies are just driving around California, and they're just collecting all this data, stuff that you'd see on the left. And then what's happening is people in and companies are actually hand annotating the data. So they're like going through the images and saying like, this is a car, this is a car, this is a car, this is a car, this is a person, this is a tree. And they're just doing that. And I'm not even joking. Literally, that's people's jobs. And they're just outsourcing this. But that's expensive. One, it takes a lot of time and a lot of money. So we theorize that if you can just somehow create an environment where you have the data already annotated, so you know where the cars are, where the trees and the people are, you can just focus on just creating the best network itself, the best algorithm, as opposed to creating the data. So the way that we did this actually is we use Grand Theft Auto, which is super fun. We wouldn't use data like this because we don't want cars to be flying into cranes. But essentially what we were doing is we were using a photorealistic engine that when you hack into the game itself, you can figure out like, hey, we know the exact locations of like where the cars and buildings and people are. So you take away the process that would normally take months and you get it instantaneously. There are some key differences. The key differences are, it's a video game and it's not completely photorealistic, but it's pretty close. So it's like this is, and the thing about research is it doesn't necessarily have to have a concrete product at the end of it. This is the difference between academia and companies, where it's like in companies, often you want like a real product that you can sell. Whereas in academia, you're just like, does this work or not? And really what we're trying to do is we're trying to figure out, does it work? So to go into like how I actually did this, let me just go 2 slides up. This is pictures that I was using to train this network actually. So I'm sorry, this is not a GIF anymore, it's just a still image. But basically what we were doing is we were taking snapshots and videos of Grand Theft Auto. We hacked into the game. I actually worked with like the number one the number one Grand Theft Auto hacker. He lives in Germany, and like he was on my research paper, and like we worked with him to just hack into the game so that we could control it, so that we could create a car, an environment that just drove in a non-crazy way, as well as so that we can change the environment. Another thing that happens with the data that's annotated by like Google or whatever is you have very limited information. So it's like you're driving around the California, like the Pacific Coast Trail or something like that, but you don't have variations in weather, for instance. Like New York is very different from California. So if you're trying to train an algorithm so that it travels, it drives in, all over the world or all over the US, you have to be able to, have data that looks like New York, whether it's the geography, but almost more importantly, like weather. Like for instance, it doesn't really snow or rain that much in California. So because of that, with a video game, you're able to control those external factors. So although you don't see anything here, so all of these, the weather and the time of day, it's all stuff that we picked, we controlled. We also included things like snow and rain so that you're able to get this mass corpus of data that is much broader than what you could get in real life, and you can get it in real time. So I use this information to more or less just train a network and kind of figure out like different things that you could do with that you can predict just based off of images and videos. So this is a diagram from the paper that I wrote. And what you see here is based off of the videos, we're trying to predict like the distance from like the lanes. So like if the car is the red car at the top, we're trying to predict just based off of the video the distance from like the left lane and the right lane, as well as like the far left lane and the far right lane. And the reason why you need all this is like when you're trying to do self-driving, you need to accurately predict where things are in the world around you. Some other metrics that we tried to predict were the angle of the car on the road. So it's like, is it like directly on the road? Is it tilted? As well as the distance from the cars to the left, right, and directly in front of it. So like in the end, like, oh, okay. So like, what does this all mean? So what this means is like, if you're able to predict the dimensions of like the world around you, then you can then go further. Like if you can accurately use like virtual data, then you can go and create like better hardware. You can create like better just networks itself. And like the data itself won't be a problem. So what we see is actually I won't go into too much detail actually, because it's actually been a while since I've looked at this data as well. But there are certain parts that work well with virtual data in predicting, distance to the cars and things like that. There are certain things that don't really work well. So if let me just pick maybe the top one. Um, so the actual truth of like that car angle is like negative zero point 0.6 radians. But we predicted it was like -6. So it's like off by a factor of 10, which is really bad. So it shows that with the data, virtual data, like you really can't do that sort of a prediction accurately. Um, but there are other things that worked very well. So it's, as you can see in like the top, if you look at car M or lane L or lane R, you can actually predict distance quite well. So it shows that although this wasn't like a huge panacea, like it wasn't able to do everything that we wanted, there are some things that you could possibly predict accurately using this virtual data. um, so just like going a little bit further as to what came out of this research. So what came out of this research is essentially that virtual data isn't completely up to par with real data at this point. And the reason for that is, although like if you look at these pictures, they don't look completely real. They're pretty close approximations to reality. But it's that like small 1% difference that makes it such that the computer isn't really going to learn it completely well. Part of the reason is, even though to us this looks like, like this looks like a normal road. I could drive on this, right? But the computers, when they look at images, don't look at the same things as we do essentially. So let me go back a little further, but let's say you're trying to figure out, like, is this a cat or a dog? Like, to us, the way we would figure out, is this a cat or a dog, is like, does it have four legs? Is it big? Because if it's big, it's likely to be a dog. It's like, or does it have like patterns on its coat, like in a stripe? Then it's like, then it's likely to be a cat or whatever. But the way that computers pick things up is it's different from us. So they would probably look at like ear shape or like distance between legs and things like that. So it's like the reason why we weren't able to probably be as accurate as we would have liked is these things that we aren't realizing matter, that are different from reality, matter to a computer. So does this mean that we should just toss this entire branch of research out? No, not necessarily. It just means that it needs to continue to be done. And if there are further improvements, then maybe it might be worthwhile to continue. But as of right now, there are limitations to fake data. So, in closing, what I like to say is like this is just one tiny example, and I've only brushed the surface of what I actually did. But there's so many huge applications to what you can do with machine learning, deep learning, or programming in general, honestly. And this is something that's not going to go away. Like the world, it's a buzzword, but like it's a buzzword for a reason. Like computer vision, deep learning is here to stay for the time being, at least. And what it's going to do is it's going to revolutionize how we approach the world in many different ways. Um, and I think everyone would be smart to at least learn a little bit about it, because even if you don't end up becoming a specialist in machine learning, you should know like how the world around you functions, especially because it's become so pertinent with like things like TikTok, where it's like things like the filters that you use are computer vision algorithms, very much similar to what I would be using to train a self-driving car. Um, so I hope you enjoyed what I was talking about, and if you have any questions, feel free to ask them, and I will answer them to the best of my capabilities.
Cool. So we're gonna let the chat sit for a little bit to see if someone has any questions that they want to add. I'm just gonna say real quick, if you want to stop sharing, you did. Okay. First off, thank you for talking to us about computer vision and how you really take this visual information and that you'd have to annotate it and make data and use it to predict relationships about the world and where we are in relation to it.
Mhm.
That seems really complex, and honestly, I didn't really realize that there are people that had to be outsourced to do annotations.
Oh, it's their full-time job. I'm not joking. It's
Part time. So anyone's interested, maybe you could do that pre-college. I don't know. No.
Don't do it. Study so you don't have to do that.
Let's see. All right. So So unfortunately, it doesn't seem like we have really any further questions regarding this. I really did enjoy your presentation, but at the same time, I enjoyed it prior anyway when I heard you talking about it to your thesis.
That's right, you were there. We knew
Yeah,
you weren't there. Were you
I
there?
was. I was okay. We'll talk later. But thank you so much again, Mark or Mr. Martinez, for being present and talking with us. Uh, I hope everyone joins us next time on October 9th when Ayana Webb talks about digital marketing strategies to help grow your brand. So she used Facebook and Instagram to advertise to grow her customer fan base. And she was able to harness these tools successfully to build a web-based lesson business with currently more than 3,000 online paid students. So
Wow.
she basically now is able to lounge back and um, really just grow her business, which is absolutely amazing. So she will unpack how to narrow down the best target audiences, create ads that grab attention, and build a quality fan base that has the potential to become paying customers. She's also reviewed Facebook ad manager platforms and how to set up ads, and that lets you collect subscriptions for your emails and take your Facebook and Instagram advertisings to new heights. So I hope you all come watch in 2 weeks our next presentation. Thank you again, Mark, for your presentation, and take care.
Awesome. Thank you. Have a great week, everyone.